Hello, everybody, and welcome back to another Mr. Parney Earth Science video. It's been a little while, but we are now transitioning from our mineral section of our geology and mineralogy unit into, as you can see on the screen, rocks. We're going to deal with rocks for the remainder of this unit. Now, there are three different types of rocks. We'll get to that in a second, but we can't really dive into this without recognizing what is the difference between a mineral and what is the difference between a rock. And the simplest way that we can think about this is that the minerals are our building blocks to create rocks. We learned the 20 different types of common rock building minerals, and they form in combinations specific to their environment to form these different types of rocks that we're going to be dealing with. And that's what we're getting into today. This is a short video because we're going to kind of break it up into sections by doing a little bit of introduction, going into igneous rocks just a little bit, and then in the next video, we'll come back and finish up igneous rocks before our lab. So here is the thing you want to get in your mind. It's the rock cycle. The formation of a rock, it determines its type. And there's three or four main ways rocks can form. Igneous rocks kind of are a 2 bullet point system here. But the thing you want to get out of this picture is that even though it's set up like a circle, we have all these kind of intermixed and interweaving arrows on the inside of this circle. So the rock cycle, it's not a perfect circle going from one rock to another rock to another rock and then back to the beginning. You can cross over, you can jump over different sections. It all just really depends on what's going on. You kind of want to follow the bouncing ball as you go through this. But we can see we have sedimentary rocks, we have metamorphic rocks, and then igneous rocks we have on here twice, depending if it's volcanic or if it's plutonic. And we'll get into that in a second, because depending if our lava is coming out of our volcano, or if we're dealing with magma that's deep underground in one of our plutons that we learned about in a previous volcano unit, like our batholiths and lactoliths and stocks and sills and dikes and all that fun stuff, we're going to get different types of rock material. Now, we'll also have weathering and erosion. We know what that means, breaking down different types of rock material on the surface. We have deposition, where they are, deposited into kind of flat, even layers. Pressure compacts them together to give us sedimentary rocks. Maybe sedimentary rocks, they go underground. Subduction, we remember that word. And then if they're put under enough heat and pressure, they become metamorphic rocks. Maybe that metamorphic rock, it melts, turns into magma, stays underground as a pluton. Maybe it goes to the surface, comes out as a volcanic eruption. So this cycle, it's not perfectly cyclical. There's many different avenues and many different directions we can go, depending the avenue our individual rock is traveling. So again, our three different types of rocks. We have igneous rocks, magma, and lava. Are you underground or are you above ground? Sedimentary rocks, it's the accumulation of sediment or different types of materials that have been broken down due to weathering. Metamorphic rocks, metamorphic means to change. So these are rocks that are being changed specifically by heat and pressure. So because of how we classify these three different types of rocks, most of the rocks at the surface have probably gone through this cycle many, many times. This is why we don't have many rocks from way back when the earth was about, formed the 4.5 billion years ago. There's very few of those rocks remaining on the surface because of the rock cycle and because it's, the rocks are going through all the different avenues and paths that they're going to take. So we're starting with igneous rocks, and igneous rocks, they were the first rocks to form as Earth cooled from that molten mass, the 4.6 billion years ago. Differentiation started to happen. And then we got all these variety of different crystalline rocks in the early crust of the earth. So igneous rocks, they were the first ones to form in our early earth, that 4.5 billion years ago. We got two different types. We have intrusive igneous rocks. Some of these words we already know, we already know what magma is. It's kind of that weird, squishy mix of rock and dissolved gases. And depending how much gas is dissolved in the magma is where we get the different types of viscous or viscosity magmas that we spoke about before, like our basaltic or andesitic or rhyolitic magmas. I know we're pulling terms back in from our volcano unit. They don't go away. We know that magma that's less dense than the surrounding rock, it's going to rise. We remember, our convection things that we learned about before. But sometimes that magma, it rises and it hits a spot where it can't go any further. And that's where we get some of those intrusive features like our laccoliths and our stocks and our sills and things like that. This magma that gets stuck underground, that's insulated, it's going to start cooling because it's away from that heat source in the magma chamber. So as it starts cooling over time, we get large crystals starting to form. This right here is granite. We'll hold it close here. This is one sample of granite, and you can very easily see the different types of rock crystals in this. Many of these minerals we have learned already. There's some feldspars in here. There is some quartz in here. There is probably some biotite in here somewhere. So we have a large variety of different minerals that we've learned in our mineral section that make up this intrusive igneous rock, and they form because of their environmental conditions. They were deep underground and they were insulated and cooled very slowly. So it's that slow cooling that gives us those large crystals in this intrusive igneous rock. Now, if we're going to talk about underground, we also got to shift and talk about extrusive igneous rock. Volcano erupts, lava comes out of the volcano, and then it cools very quickly to form the rock. So quickly sometimes that the crystals are so small you can't even see them. So if we go from our intrusive intrusive granite here, that you can easily see the different minerals that make it up, and then we compare that to our obsidian, which looks so uniform, so homogeneous, that it looks like that there are no minerals that are actually making up this rock, but they are. The difference is this is an extrusive igneous rock that cooled at the surface very, very quickly, did not have enough time for those crystals to kind of grow and form. There are crystals that make up this rock. You just can't see them. So that's a big difference. If we put them side by side here in my camera, intrusive igneous rock, you can see the crystals because they had more time to form. Extrusive igneous rock, they cooled very quickly, very hard to see the crystals in our extrusive igneous rock without some sort of aid like a microscope or something like that. So being able to differentiate between those two types is going to be very key to figure out what type of rocks we are dealing with here. The last two things that we're going to talk about is how we can begin to classify different types of igneous rocks. We do that based on their texture and their composition. If we remember back to our mineral section, when we were trying to classify and identify the 20 different common rock-forming minerals, we had different tests that we conducted. We looked at the color, we looked at the luster, we did our hardness tests, we looked for any special properties, we streaked them, all of those things to figure out what minerals we're dealing with. Igneous rocks, if we're doing the rock as a whole, it's a lot easier. We look at the rock and we say, what is the size, shape, and arrangement of the different minerals in this rock? So we are observing the rock. We don't have to perform any difficult tests. It's just you look at the rock, you answer the questions, you follow a flow chart, and you see which one you're dealing with. So these questions could include, is it intrusive, coarse-grained, like this, coarse-grained? This is what an intrusive coarse-grained rock looks like. Is it extrusive, fine-grained, like this? Is it glassy? This is a glassy igneous rock. Or is it porphyritic? So all of these questions that we have, or vesicular. All of these questions that we have, it's a new set of questions, but the idea behind it is the same as when we were dealing with the minerals, is that we follow and answer these questions. We look at a specific kind of flow chart to follow through, and then we see what we're dealing with here. So texture is the one, composition is the other. What are my rocks made out of? These are words we already know. Basaltic, granitic, andesitic. These are different types of magma, and it is determined by the amount of silica, iron, and magnesium found in these different materials. Is my magma going to be mafic? Is it going to be intermediate? Or is it going to be more of a felsic material? So we already kind of explored that a little bit when we were doing volcanoes. We're just kind of tail ending back to it today. So that's where we're going to end the video. In the next video, we're going to get specific and talk about the different types of information we look for as far as texture goes and as far as composition goes, to really get a good idea of how to identify igneous rocks if we're looking at them in hand sample. So if you were not in class today when we did these notes, what students did beyond this was they worked on drawing their own rock cycle diagram on a piece of paper. Let me grab one real quick as an example so you can see what we're dealing with here. Here's one that a student did. And again, they can be very simple and just kind of draw what they saw on that first slide. This is kind of their own personal rock cycle now that they can use for their own notes. Some students also had time to put some information on the back of their worksheet about igneous rocks. Now, I had students separate the back of the worksheet into 3 sections, one for igneous, one for sedimentary, and one for metamorphic. That way, when we go through the sedimentary and metamorphic, you have a column on the back of this worksheet with the rock cycle to put some important information on. So you're slowly creating your own kind of personal rock cycle guide to help you study this material as we go through the 3 different types of rocks. So really good idea to go about doing that. All right, that's all I have for this video. If you have any questions, please go ahead and reach out. If not, have a good rest of your day, and I'll see you next time. Take care.